Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole, and with me again today is Brian. We're both from Calgary, Alberta. Welcome, Brian.
Thanks for having me again. It's 3 episodes in a row now.
Sure is. Third time's a charm.
I hear it is.
This week in engineering news, we're talking about vertical wind turbines. Not just the traditional propeller wind turbines that we see all over southern Alberta. This one's a little bit different. The vertical axis wind turbines spin on an axis that's vertical to the ground rather than horizontal, which explains the name, which offers increased performance when arranged in a grid, which means that they can be designed much closer together.
That seems like a pretty important thing to do if you're building a giant wind farm.
Yes. So these vertical axis wind turbines, to me, they look like there's lawn ornaments that have kind of a spiral element around a stick, basically, and they spin when it's windy.
Or like a DNA helix.
Yes, like a DNA helix, which is a much better explanation than my lawn ornament whirly-doos. Thank you.
Not a problem.
As I said before, they're more compact and efficient, and when they're set in pairs, not only do they not limit each other's performance, but they can increase it by about 15%. So this came from a study that was done by the School of Engineering, Computing and Mathematics at Oxford Brookes University, and they did an in-depth study with over 11,000 hours of computer simulation.
Which is 5 years of full-time work equivalent.
Wow, that's a lot.
Actually, almost 6 years worth of full-time work equivalent.
I actually don't know how long this study took. I'm assuming they used multiple computers.
Probably, but it's still a lot of time.
That is a lot of time, yeah. So the study allowed them to look at array angle, direction of rotation, turbine spacing, and number of rotors without investing the large cost of experimental test facilities, which is really important and something that's really improved in the last 20, 30 years in engineering. We can test a lot of the designs on the computer before we have to spend the money building prototypes and materials to test in real life, which is really interesting. And it also allows us, related to this show, it allows us to test for failure points electronically instead of building something and doing all the math and then building something and
testing it to destruction. We can just see it destruct on the computer now.
Yes, exactly. So in a traditional horizontal axis turbine, which is the propeller ones that we see all over southern Alberta, when wind hits the first row, it generates turbulence, which impacts performance of the rows behind it. So while the front row might convert half of the kinetic wind energy to electricity, the back row might only convert 25 to 30%, which also doesn't really... I understand why it happens, but it almost, to me, seems silly why put the back row in. Why put them in a farm like that if that's going to happen? This couldn't come at a better time, these vertical axis wind turbines, because the Global Wind Report of 2021 said that the world needs to implement wind power 3 times faster over the next decade to meet net zero targets. So hopefully these vertical wind turbines will help us get there. You know, wind is an important part of our energy diversification process. You know, there's wind, solar, water, nuclear, and then fossil fuels. So I'm sure there's more than just those, but you know, wind is an important part of that. Anything we can do to make that system more effective, more robust, higher performance is good for all of us. If you want to read more on the vertical wind turbines, check out the link in the show notes or head to failurology.ca for more information.
This week's episode of Failurology is brought to you by CRISPR. Not the genetic engineering technique, but your vegetable CRISPR.
Actually, this isn't a sponsor. It's a PSA. You should probably clean out your vegetable CRISPR. There's definitely a cucumber or box of mixed greens you bought last week or last month or last year that needs to go.
We're not here to judge. We can't see your fridge. We won't even know whether you cleaned it out or not, but you'll probably feel better if you do. On to this week's engineering failure. The Kursk Submarine. A faulty weld on a practice torpedo led to an explosion of high-test peroxide and a secondary detonation of 5 to 7 torpedo warheads, ultimately sinking the Kursk. The Kursk was a nuclear-powered Oscar II class submarine of the Russian Navy. The Kursk was reputedly unsinkable, and there were claims that it could withstand a direct hit from a torpedo.
Which is crazy. Did we not learn from the Titanic that ships can sink?
I feel that things that are supposed to be unsinkable generally aren't unsinkable.
Because that is a fallacy. It's so silly. It's surprising that we're back here. Sorry, carry on.
There's a lot of things that were unsinkable that have sunk for sure.
So many.
So the Kursk had an 8mm outer steel plate hull covered with 80mm of rubber, which made it much harder to detect from surface sonar and other submarines. The inner hull of the Kursk was made of 50mm steel plate and separated from the outer hull by a 1 to 2 meter gap. So this inner hull was divided into 9 watertight compartments, and the Kursk was as long as 2 747s, which is pretty long.
Yeah, that's pretty huge. So we did the Comet 2 episodes ago, and it was about the same length as the 747. So this is twice as big, which is, yeah, it's weird. You think of a submarine as being claustrophobic, but there was 118 people on the Kursk when it sank. So speaking of it sinking, on August 12th in the year 2000. The Kursk was part of a naval training exercise in the Barents Sea off the northern coast of Norway and Russia.
And this was the first major Russian naval exercise in 10 years, right after the collapse of the USSR.
Yes. The USSR collapsed between, I believe it was a 4-year period, so I believe it was between 1988 and 1991 that the collapse occurred.
Yeah, that's correct. Actually, I remember watching when they lowered the USSR flag when the USSR was essentially disbanded. I remember watching that on TV as a 8 or 10-year-old kid, and I didn't fully grasp the significance of it, but looking back, that was a monumental shift in world geopolitics.
That's insane that you remember that. I definitely don't. I would have been a little bit younger. Do you ever play really old board games where the USSR is still a country? Because sometimes I play this trivia game from the 1980s and the USSR is in fact a country, and it's really interesting to hear the questions.
I've definitely played board games like that. With sometimes when we play Trivial Pursuit, you have to have the correct answer for that era.
Right.
So even if a country's disbanded, when the card was written, Czechoslovakia might be the correct answer, and we do not accept Czech Republic or Slovak Republic. Yeah, it's a good way to play board games with people that play a lot of trivia. Adds another element. But we should get back to talking about the Kursk.
Yes. So during this naval training exercise, there were 118 personnel on board. Unfortunately, when the Kursk sank, they were all killed, but not right away, and we're going to get into that. The crews on nearby ships felt the initial explosion, and then they also felt a second, much larger explosion. So there was, again, we're going to get into this, but there was the initial explosion, which all things considered was minor, but it set off the second explosion. Now, the Russian Navy, even though the nearby ships felt the explosion, which were Russian ships, the Russian Navy didn't realize that an accident had occurred, and they didn't initiate a search for more than 6 hours.
So with the Russian Navy not realizing that there'd been an explosion, was that they just figured it was part of the naval training exercise for torpedo launching or launching missiles? Or
from what I've read, I think everyone just assumed that wasn't, whatever they felt wasn't the Kursk exploding wasn't the Kursk sinking or experiencing any type of accident, because the Kursk was infallible. It was an unsinkable ship. There was no way it could be the Kursk. And so they kind of just ignored it.
And the Kursk was one of the best submarines in the Russian Navy as well. It was kind of the elite submarine in the Navy, from what I understand.
Yeah, and I believe the crew was also the top of the top. It seems like everyone just assumed that wasn't the Kursk, even though it was in the same location as the Kursk, and all things, I guess hindsight's 20/20, but all things kind of pointed to it being the Kursk, but they definitely didn't realize that at the time. On top of them ignoring that explosion for 6 hours, there's a rescue buoy on top of the Kursk that is supposed to deploy automatically if there's a large pressure change or any type of significant event that occurs on the ship. But it was disabled during an earlier mission. And so once Russia did decide to start a rescue mission, it took them 16 hours to locate it. So,
and do we know why that rescue buoy was disabled in the first place? Like, that seems like a fairly important thing to have operational if something does go wrong.
We do. So the rescue buoy is located on top of compartment 7. So remember, there's 9 compartments, and like I said, it was meant to automatically deploy if there were any emergency conditions, so a fire or a rapid pressure change. But they were afraid that this rescue buoy would accidentally deploy itself at an inopportune time, which, I mean, is kind of a reasonable fear to an extent. And they disabled it. On top of that, the buoy was problematic, so it was a little bit faulty. And so they disabled it before the accident had occurred. They had already basically turned it off. I mean, I don't think it's quite that simple, but yeah, they had disabled it on their own.
I guess that makes sense if you're a submarine and the rescue buoy can give away your position if you're conducting operations and let the enemy forces know where you are. So I guess from a tactical standpoint, it makes sense to disable it. But yeah, it's unfortunate that the rescue buoy didn't deploy in this situation.
Well, also, I mean, you could build a better rescue buoy. The one that they built was the faulty one. They could build something that's better.
Russia didn't have a lot of money at this point in time.
Fair enough.
So that may have contributed to it.
Once they did locate the Kursk, over 4 days, the Russian Navy made 4 failed attempts to attach diving bells and submersibles to the escape hatch. So diving bells are a chamber that they use to transport divers from the submarine to the surface. It took them 4 days to attach it.
That seems like a really long time to get something attached to a submarine that could save lives.
Yeah, so, I mean, what we know now, unfortunately, everyone on board was already dead at this point. We know that there were people that survived both explosions, and we're going to get into that, but Russia was very reluctant to accept help. After 7 days, they finally accepted help from the British and Norwegian divers, and they were able to open the escape hatch in the flooded 9th compartment, but like I said, there were no survivors at the time. I think one of the problems with getting the diving bells to attach, especially on the British and Norwegian side, were that Russia didn't follow the same world standard, we'll say, for sizing. So it's like when you buy a bed from IKEA and it's just a little bit different than the bed sizes, bed dimensions you get from a different place. You know, it's almost like IKEA doesn't quite fall.
Or imperial and metric wrenches.
Right.
Like I do design work in both imperial units and metric units, and sometimes they're so close, but they're just not quite the same conversion.
Right. And so the British and Norwegian diving bells weren't easily attachable to the Russian ship because the Russian ship used different dimensions and different mechanisms to attach their diving bells. So there wasn't kind of a standardized system that allowed other countries to step in easily and rescue it. They had to modify their equipment.
Yeah, and we weren't that far out of the Cold War where NATO countries wouldn't even consider needing to rescue submariners or other people trapped in a submarine, where it would be important to be able for their rescue equipment to interface with the Russian submarines. So
yeah, but I think even today on the International Space Station, you know, the space station's kind of 2 compartments. There's the Russian compartment and everybody else. And I think that there's some overlap in compatibility just because, you know, you're up in space and you don't really have a choice, but the mechanisms that the Russian side uses are different than the American or the other side.
Yeah, the docking mechanisms, I believe, is the 2 that are different for the STS when that was operational, and then the Soyuz capsule that they use now.
Yeah.
On August the 12th of 2000, Summer X, the first large-scale Russian Navy exercise in more than a decade, really since the fall of the Soviet Union, was conducted by the Russian naval forces. And this exercise included 30 ships and 3 submarines. And one of the submarines, like we talked about, since it's what the episode is about, the Kursk, was involved in this large-scale naval exercise. The Kursk was essentially the flagship submarine of the Russian submarine forces. It was incredibly well equipped. The crew was incredibly well trained, and it was one of the only, or possibly the only, Russian submarine that was allowed to carry, or was authorized to carry, a full combat load or a full complement of conventional weapons and torpedoes on board, even during a training exercise. As the training exercise went along, at 8:51 a.m., the Kursk requested permission to conduct a torpedo training launch and received the go-ahead from Naval Command. After a 2.5-hour delay, the Kursk set to fire 2 dummy torpedoes, and at 11:29 a.m., the first torpedo was loaded without a warhead into the number 4 torpedo tube on the starboard side of the Kursk, or the right-hand side for people that aren't well-versed in marine-related things.
Brian, do you want to know my trick to remembering which side is which? Port and left are the same side, and left and port are both 4-letter words. So therefore, starboard must be the right because it's not a 4-letter word.
That's a good way to remember things. So the torpedo that was loaded into the number 4 tube was 10.7 meters long and weighed 5.5 tons, which seems like a pretty heavy torpedo, but I'm not a naval munitions expert at all.
Well, it's definitely, you're not hand bombing it in there.
No.
You're definitely lifting it with some kind of crane. It's big.
At 11:29:34 a.m., seismic detectors at the Norwegian Seismic Array, or NORSAR, recorded a 1.5 magnitude seismic event in the area where the training exercise was taking place. So this would have been the first explosion that we talked about earlier. Then at 11:31:48, 2 minutes and 14 seconds after the first detection, NORSAR detected a 4.2 magnitude seismic event about 400 meters from the initial event, suggesting the submarine sank 108 meters and sat on the seafloor between the two events. The second event was 250 times larger and registered across northern Europe. Additionally, a Russian sub and battlecruiser also that were part of the exercise felt the explosion. The Russian sub thought it was part of the exercise, and the ship reported a hydroacoustic signal characteristic of an underwater explosion and felt their hull shudder. Fleet headquarters for this exercise ignored their reports.
So those are the ships that recognized the explosion and raised the alarm to the Russian Navy, and the Russian Navy ignored it for at least the first 6 hours, like we've mentioned before. There were 4 different rescue attempts, and they all failed for various reasons. The British, Norwegian, American, French, German, Israel, and Italian governments all offered assistance almost immediately, but were turned down. That's a lot of rejection.
That seems like a lot of governments that are offering assistance after they officially find out that the Kursk has sunk.
Yeah.
And the Russians turned down all of this assistance initially, right?
7 countries offered to help, and one of those is American, which is honestly a little surprising. Norwegian divers eventually managed to open the flooded 9th compartment, but unfortunately they didn't find any survivors. Russia had operated 2 India-class submarines that carried deep submergence rescue vehicles, or DSRVs, but these submarines had been held at a shipyard for the last 6 years due to lack of funds.
This seems like a terrible situation that, something that can rescue people that are trapped in a submarine is essentially in port because you couldn't pay your bills.
It does, for sure.
So as part of the rescue effort, there was a Russian ship that was dispatched to the area that did carry 2 submersible submarines that had to be lowered from the ship. The first submersible that was launched from the ship made contact with the Kursk and it was damaged, so they had to pull up the first submersible that they lowered down to attempt the rescue effort.
How did it get damaged?
It literally just ran into the Kursk.
How?
So they found it. They found the Kursk and then collided with the Kursk. Which sounds like a terrible thing. It's like if a fire truck came to put out your house fire, and then the fire truck just drove into your house like that. You're off to a bad start in an already bad situation.
Yeah, very bad start. Are these manned ships or are they driven by remote?
So they're remotely controlled, or there's wires that go down to these submersibles. So they're driven around from the ship.
Okay. That's a little bit more forgivable. Not only slightly. Yeah. Like very slightly.
It's not a good situation to have happen when your rescue vessel runs into the thing you're trying to rescue. I feel it's not a good situation.
No. Well, we're already off to a bad start. Why not continue?
We might as well. So it gets worse. It gets much worse. This is only the start. But they have two submersibles, or a second submersible. The Russians launched a second submersible, but the second submersible can't locate the Kursk.
I say again, how? The first one ran into it, and now the second one can't find it?
Yeah, and the second one can't find the Kursk because it was provided with the wrong heading information. So the first one had great heading information. It was so good that it just ran into the Kursk.
Is heading information, is that like coordinates?
So the heading would be what direction, what compass direction they needed to go from the launch ship or the launch point to get to the Kursk. So the first one, really good at finding it. Second one, not so much. They pull the second submersible they launched back onto the boat. The second submersible was relaunched, but they were unable to place a diving trunk on the Kursk. As part of the the effort to place this diving trunk on the Kursk that was unsuccessful. They wound up depleting the batteries on this submersible.
How do you
So
do
not
that?
only did they not get the diving trunk placed on the Kursk, they ran out of batteries. They bring the second submersible back up, don't have any backup batteries that they can just put into the second submersible. So they wind up having to recharge the batteries. And by the time that these batteries are recharged, the winds are too strong and the sea is too high for them to put the submersible back in safely to attempt this rescue effort again.
Russia, this is embarrassing.
But it gets worse. At 8 p.m. on Tuesday, the first submersible was relaunched, but was damaged being lowered into the water. It was repaired and launched again. In addition to this first rescue vessel that had the two submersibles on it, a crane ship with a much more maneuverable submersible was brought to the site, but weather got the best of it, and they weren't able to launch the submersible that was carried on this crane ship. Now, going into Wednesday, just after midnight on Wednesday, the first submersible that was launched made 2 attempts to attach a rescue trunk to the sub. Both, unfortunately, failed.
I'm shocked.
Yeah.
Completely shocked.
In addition to not being able to attach the trunk, they broke the submarine again. So when they were lifting the submersible back onto the boat, they severely damaged the propulsion system. So in order to make it work again, they cannibalized the second submersible that they had for parts for the propulsion system. And as most repairs do, it took a significant amount of time. So at this point, we're 5 days into the rescue effort, and we've damaged multiple submersibles. We've parted out our second submersible into the first one to even make it work. We've brought an additional ship, but it took too long to get there, and the winds were too strong, so it wasn't able to lower its submersible to the Kursk. All around, over 5 days, they've essentially failed at every rescue attempt that they've made.
Yeah, this is not going well. The British are coming. The British are coming. I just wanted to say that.
But the British do come. The British do come.
Yes, eventually the Russian government accepts foreign help to rescue the submariners trapped aboard the Kursk. Unfortunately, 5 days, they're a bit late. 6 teams of British and Norwegian divers arrived on Friday, August 16th, which is 6 days after the incident occurred. And the Norwegian divers were finally able to gain entry into the Kursk, but found the 9th compartment flooded with water. There were delays in opening the rescue trunk due to the Russian Navy stating the incorrect direction to open a valve.
So, I've opened a couple valves in my life, and they either turn clockwise or counterclockwise. And I would think that with as high level and as high tech of a submarine as the Kursk would be, they would know what way to open the valve.
Lefty loosey, righty tighty. Isn't that the way? Unfortunately, on August 21st, Norway officially confirmed that there were no survivors in the Kursk. And on July 26, 2002, Russia announced that hydrogen peroxide fuel in the dummy torpedo inside the 4th launch tube set off the first explosion.
So, Nicole, what is hydrogen peroxide fuel? It's not a fuel that I've heard of before.
It's a high-test peroxide. It's an 85 to 98% solution, with the remainder being water. And when the high-test peroxide comes in contact with a catalyst, which in most cases would be kerosene for this type of exercise, it expands 5,000 times its original volume and turns into steam and oxygen. So essentially, they're using the reaction caused between the high-test peroxide and the kerosene to act as a propellant to fire the torpedo and propel the missile higher and further than it would with other types of fuel. It's known as a pretty dangerous fuel method.
Yeah, it sounds like it's a pretty dangerous fuel system to carry. I mean, it expands really fast, and it obviously gives you a lot of propellant that you'd otherwise have to carry in weight, but it also seems very dangerous.
Yeah, and this isn't the first time this has happened. In 1955, the HMS Sidon, a Royal Navy submarine, sank due to high-test peroxide exploding in the torpedo tube. I believe that would be a British submarine. So this is not the first time this has happened. Most other countries, from what I've read, have gone away from using high-test peroxide torpedoes, but for whatever reason, Russia had not, at least at the time. I would assume by now they have, but who knows?
So there's a 45-year difference between these two incidents that sound fairly similar, or at least have the same root cause.
Yes, yeah. Yeah, but I mean, they also thought, 90 years later after the Titanic sank, which was also supposed to be unsinkable, that the Kursk could be unsinkable. So, I mean, we don't seem to learn from our mistakes as a species, it seems.
I've certainly made one or two mistakes once or twice.
I mean, it happens, but this is pretty major. And also this is a series of unfortunate events. This isn't one thing going wrong. And I mean that's kind of a theme with the failures that we've researched on this show, is that it's never one thing that goes wrong. It's always a series of things, because there's usually enough safety factor and enough protection that if one thing went wrong, it's okay. You can manage. It's not the best case scenario. Maybe maybe there can still be consequences, but it's usually not quite as catastrophic. But when a series of things go wrong, it's just it's catastrophic. So Russia released a 133-volume top-secret report in August 2002, but only a 4-page summary made it to the public.
That seems like a huge difference. Like 4 pages versus 133 volumes.
Yeah, I am not surprised. I mean, after everything we've already talked about, does that surprise you at all?
Not in the least.
Okay, so the 4-page summary stated that, quote, there were stunning breaches of discipline, shoddy, obsolete, and poorly maintained equipment, end quote, as well as, quote, negligence, incompetence, and mismanagement, end quote.
It sounds like this is just all around not a great situation for anyone to be in, and it was made even worse by the rescue attempts.
Yeah, the rescue attempts are really bad, but also how the accident occurred in the first place is also really bad. We kind of went a little bit backwards. We talked about the rescue effort first, and now we're going to talk about what caused the initial blast and the secondary explosion, which I think in themselves are very interesting. There was a 470 millimeter air conditioning duct that passed between the first and second compartment bulkhead in the ship. So the first compartment is where all the torpedo tubes are, and there was this duct that passed between that compartment and the other compartment. And there was a valve in between the two compartments that was intended to be closed.
What would the valve do between those two compartments? I've never been on a submarine.
Neither have I, but my guess would be, since both compartments are supposed to be fully watertight, that the valve would have allowed that compartment to be watertight. And so that valve is probably supposed to be closed, or at least to automatically close, so that if there's an event in compartment 1 or compartment 2, it can't transfer into the adjacent compartment.
Oh, so some sort of isolation valve then.
Yeah, that would be my guess. And so that valve was left open at the time to minimize any pressure changes during a weapons launch, which sounds like somewhat of a standard practice. But the open valve is believed to have allowed the first blast to expand into the other compartments, and also allowed a fire to start that burned at 2,700 degrees Celsius.
That's like 5 times what the normal oven temperature is. More than 5 times.
Yeah, because you're thinking 5 times in Fahrenheit, and this is in Celsius.
Oh, yes, that's even worse.
Because this duct allowed the fire to spread, it ended up going as far back as the 4th compartment. And the command post was located in the 2nd compartment, but since it was damaged and those people were incapacitated, if not already unfortunately dead at the time of the first explosion, they were not able to send any distress signals or send the submarine to surface.
That's really, really unfortunate.
Yeah, there's kind of almost, it sounds like almost like an abort button, that you push that button and it just sends the sub to surface, which, had that occurred, that would have been really good, because then the people in the 9th compartment that actually survived the second explosion would have been able to just open the hatch and they would be at sea level.
And they wouldn't have had to go through all the rescue attempts with the submersibles.
Exactly.
But wait, there's more. 2 minutes and 14 seconds after the first explosion, a fire that was caused from that explosion sets off 7 combat-ready torpedo warheads. The Kursk was one of the only submarines in the Russian Navy that was allowed to carry a combat armament in training situations.
And it didn't set off 1 warhead, not 2 warheads, not 3, 7.
Not even 5, it set off 7 warheads.
It's a lot.
Under normal operating circumstances, there would have been 78 crew members in the first 4 compartments and 49 crew members in the rear 5 compartments. The Kursk's hull could withstand external pressures of depths up to 1,000 meters, which is about 9,800 kilopascals, but the second blast opened a 2-meter square hole in the hull, and the first 4 compartments flooded with seawater at a rate of 90,000 liters per second.
It's a lot of bathtubs.
That's many bathtubs. That's a lot of water coming in at a lot of pressure.
Yeah.
The official Russian government inquiry identified the cause of the initial explosion on the Kursk to be a faulty weld on one of the practice torpedoes. Sources within the Russian government stated that at least one of the practice torpedoes was dropped during transport, which possibly led to the torpedo cracking. Being as it was a practice torpedo, it likely had less stringent inspection that was required for it, since it wouldn't have actively been launched in a combat situation. Also noted were that the rubber seals were leaking fuel. No action was taken due to the importance of this training exercise, again being the first training exercise Russia had conducted in many, many years with their navy. The torpedo came from a batch that was manufactured in 1990 that were initially rejected due to faulty welding. And again, since they were never intended to carry warheads, the welds were not carefully inspected or re-welded or taken out of service. Also, the torpedo launch tube showed signs of distortion near an essential weld, which led the Russian government to believe that the faulty weld led to the explosion.
So, as we talked about earlier, there was a rescue buoy on top of compartment 7 that never deployed and is a large part of why they weren't able to find the ship. But the Kursk also had an escape capsule, which was located in the third compartment. That compartment, unfortunately, was inaccessible because the explosions took out the first 4 compartments, and those first 4 compartments were no longer accessible by any members of the crew. There was also an escape capsule in the first compartment, but of course it was destroyed. I personally have never designed or been on a submarine, but I think 2 escape capsules is maybe not enough, or at least locating them in the first and third compartment seems a bit silly.
Yeah, that seems like all the escape options are in the front part of the submarine, where maybe they should be more spread out. The second compartment, the sixth compartment, and the ninth compartment.
Why did you put them where all the explosives are? That's the part that I think is most confusing to me. You put them where the bombs are.
Maybe that was the only space that they had left after they designed the rest of the submarine.
Well,
Just
yeah.
tried to cram in the rescue compartment.
One thing that I think is really interesting, I find this so fascinating. So the sub was nuclear powered, and there were 2 reactors on the ship. They were located in compartment 5. Now, compartment 5 was surrounded with 130 millimeter thick steel, and that compartment withstood both explosions. The reactor shut down automatically, and there was no nuclear meltdown or any contamination.
Finally, something that goes right in this.
Something went right. I think this is, to me, the only real silver lining of this entire exercise is that they didn't have a nuclear meltdown, because Russia already had Chernobyl, and they didn't need anything else. And this has already gone so poorly. But what I find so interesting about this is I speculate, now having never designed a submarine, but I speculate that the reason compartments 5 through 9 survived both explosions is because the nuclear reactors in compartment 5, that 130 millimeter thick steel compartment, almost acted as a stopgap. So I think had the nuclear reactors been in compartment 9, the first 2 explosions would have probably blown through the first 8 compartments. But I think because those explosions reached compartment 5 and they kind of couldn't really go anywhere.
Yeah, that steel just absorbed so much of that blast damage from the initial explosion.
Yeah, which is so fascinating, I think, to me anyways. And it makes me wonder, and maybe you don't put the reactors so close to the explosives either, but should you put thicker steel between your compartments? Do you make the second compartment where the command center is, do you make that also really, really thick as well, so that, in the future, this type of thing couldn't blow out multiple compartments? Obviously the first task we want to accomplish here is to not have this explosion happen again. But if you're going to protect and put, extra protection in to protect yourself should this happen again, to me, that seems like a really good option to at least look at, which I just found that piece so interesting. So there were also a bunch of other explanations as to why this explosion occurred. They ultimately decided that it was a faulty weld, but there was a lot of other options that they came across before they got to that. So I'm just going to kind of list them here. Some of them are a little more out there than others, but they looked at inadequate training, poor maintenance, and incomplete inspections. The crew had no prior experience with or been trained on handling this high test peroxide torpedo, even going as far as to fake documentation. So it sounded like the officers or generals or the people above the people on the Kursk faked documentation to say that the people on the Kursk that were loading these torpedoes were qualified to do so when they weren't. Also, I found this really interesting as well. So the torpedo tube has two doors. It has an inside door that's obviously inside the ship and an outside door on the sea side. And so the internal door was designed to be 3 times as strong as the external door. And the reason for that was that if there was any type of explosion that happened in the tube, then it would be directed out to sea because the weakest point fails first. That weakest point is the outside door. And so the explosion out to sea. But when they brought the Kursk up and they investigated further, the investigators believed that the internal door was not fully closed when the explosion occurred, which would have obviously prevented it from directing that explosion force out to sea. And one of the reasons that they believe that the door wasn't closed is because there's electrical connectors between the torpedo and the door that were unreliable. And so the crew had to open and close the door multiple times so that those contacts would register. And they were likely in the process of doing that or when the explosion occurred, because from what I have read, it doesn't sound like the explosion occurred when they hit go. It sounded like the explosion occurred as they were loading the torpedo into the tube.
Yeah, that's really unfortunate that the timing didn't work out for the door being closed when the explosion happened.
Yeah. One last thing I wanted to mention that came out of the investigation was that when they did finally investigate the Kursk and open up the 9th compartment, they found a note that stated 2 hours after the second explosion, and it records there being 23 survivors in the 9th compartment. What I read was that all of the survivors moved into the 9th compartment, so there was 23 of them at the time. The 9th compartment, although mostly intact, was starting to take on water. Not super quickly, but it was still happening. And I don't know exactly how, but one of the crew was involved in some kind of small chemical fire. They had chemical burns on their torso and their chest. And when that fire happened, all of the other crew members went underneath the water. It was probably about at waist level at that time. And all those crew members went under that water so that they obviously wouldn't get burned, but the fire ate up all the remaining oxygen. And so when the men came back up, there was very little oxygen left for them to breathe, and they ultimately suffocated, which is very unfortunate.
There were a number of conspiracies that were put forward in regards to the sinking of the Kursk. So the first one that came up, maybe there was an explosion in the high-pressure air tanks used to blow the ballast tanks that were located near the torpedo tubes. The Kursk might have been struck by a missile, either from the Russian training exercise or from other NATO forces that were in the area that were monitoring the exercise. There could have been a Chechnyan espionage attempt, just human error, sabotage overall, or possibly that the Russians were testing a new top-secret torpedo.
As we've mentioned, they eventually brought the Kursk up to sea level to investigate it. And this process is so interesting. I find this whole story really interesting, but one of my favorite parts might be that to do this, they towed it underneath a deck barge to a dry dock. So I had pictured that they would tow a boat, some kind of large barge, obviously a really big boat. This thing's 2 747s, so it's not really easy to move. They would bring this large ship out there. They would use something to bring the Kursk up to the surface, and then they would use a crane to lift it onto the top of this barge, and then they would bring the barge back to the dry dock or the dock. But they didn't. So what they did was they brought it up to the underside of this barge and they towed it under the water.
That is so cool.
I know.
I would have never thought that was how you would move this submarine from the bottom of the ocean floor to the surface of the water, but not above the surface of the water, and then essentially just drive the barge with a submarine attached to the underside of it to the docking facility. That is super cool.
It's fascinating. They did cut off the bow of the ship because there was still warheads on it, and they were afraid that it would fall off while they were lifting it and destabilize it.
That seems like a pretty reasonable thing to do.
There were also some pretty strong currents in the Barents Sea, so they towed it obviously very slowly, but yeah, so fascinating that they brought it underneath the barge.
So there you have it, the sinking and the multiple failed rescue attempts and the ultimately successful rescue attempt of the Kursk submarine. Whatever the actual cause, and as with all of the failures that we've covered on this show, many things went wrong. It was a series of unfortunate events: the faulty weld, the location of the escape capsule, failure to launch the rescue buoy, and of course, the multiple poor rescue efforts. Just like with the Titanic that we covered in episode 11, unsinkable ships do in fact sink, and one should always be prepared. The only real silver lining that I can see here is that the nuclear reactor shut down safely and didn't melt down. Chernobyl was already bad enough, and this could have been just as bad or even worse.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find it. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com, or you can connect with us on LinkedIn. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode for another special engineering marvel. If you've been following the show, every 10th episode we cover an engineering marvel rather than a failure. And next episode's marvel is the Panama Canal. But more on that next time. Bye everyone. Talk soon.